In this section, we're going to continue to work with triangles and proportions. However, what we're going to introduce is a new type of segment, and then also parallel lines and what those have, what types of properties those have within triangles. So starting with what we have that's called the triangle proportionality theorem. All it basically says is if we have two lines that are parallel, and obviously it would have to go through the other side of the triangle, then what it does is it cuts these sides into proportional parts. So if I take AB and put it over BC, then that will equal AE over ED. Now the converse of this is also true. So if this line intersects two sides and it cuts proportional parts, then the lines over here are parallel. So if you set up your proportion, find out that they are in fact equal, then that automatically makes these two lines parallel. A midsegment of a triangle is our next term, and basically all that is saying is you take the midpoint of two different sides and then you draw a segment to connect them. That's it. So MH right here would be a midsegment, and that's denoted by the fact that this GM is congruent to ML and then GH is congruent to HK. Along with the midsegment comes the triangle midsegment theorem. And basically what that is saying, all right, so if MH is a midsegment, well then what's really nice about it is that MH is half of LK. So not only is it, is it going to be parallel to that side and all that good stuff, but it's also half of the length. So it takes away a lot of the guessing work or having to set up a proportion. You just do half of this one to get that one. All right, proportional parts of parallel lines. So this time we have parallel lines. So you notice that we have three parallel lines here. And remember, that's what those black triangles mean. And we have two transversals. Well, the transversals, what they do is they cut these pieces into proportional parts. So I can take little segment AB here and put it over BC here, and it will equal QP over PR. And it will always work, no matter how far apart they're spaced or anything like that. It's always going to be set up that way. And then we have congruent parts of parallel lines. So again, same picture, three parallel lines, we have two transversals. But you'll notice that only AB is congruent to BC here. That's all that's given to us. However, because these lines are parallel and because these are given to us as congruent, that automatically makes these two congruent as well. Now they're not congruent from one line to the other, just within the same line. AB and BC, and then QP and PR will be the same. Okay, so let's go ahead and do these examples, and I actually uploaded a PDF for you again so that you would have you would have them already kind of drawn out for you to save you all that extra work and messiness that comes with it. So in number one, we have parallel lines. Because of the parallel lines, that automatically introduces proportional parts. Well, you'll notice right here, this whole side is 33, right? Well, if the whole thing is 33 and this length right here is 11, then this one here has to be 22 because 33 minus 11 is 22. So then you can go and set up your proportions now. So x over x plus 12 equals 11 over 22. There you go. Do your cross multiplying. So you get 22x equals 11x plus 132, if I'm not mistaken. Let me just check on that. Yes, okay. All right, I'm right. And then you subtract 11x from both sides of your equation to get 11x equals 132. You divide by 11, and x is 12. So there you go. Now, of course, you can always plug it in and double check to make sure that it actually works. And so I'm going to go ahead and check it. I'll put x in here, 12. That was easy. If I put 12 in right here, then this whole side is 24. So does this fit? Well, you'll notice 11 is half of 22 and 12 is half of 24. So we know that we have the right proportion set up. All right, number two. So we have marked off a congruent segment here and here. So that means this right here is a midpoint, right? Oh no. All right, and then that means because this is congruent to this is also a midpoint. So if those are both midpoints, then that makes this line right here what's called a midsegment. So that is a midsegment. Well, what did we say a midsegment does? Well, a midsegment is half of this length. So to find x, we find out what is half of 35. That's all you have to do. You just divide 35 by 2 to get a total of 17.5. There you go. All right, now number 3. So parallel lines here. And so that just means we have proportional parts. So remember, keep it consistent. If I do 24 over x and I use the top part first, then I have to use the top part first in the other one. So 30 over 10. Cross multiply to get 240 equals 30x. Divide by 30. And you would get that x is 8. There you go. And if you were to plug this in and double check, so let's say I put 8 right here, 24 over 8 is 3, and 30 over 10 is also 3. So we know for sure that we have solved this correctly. All right, cruising right along. Next example, now we are into the parallel lines. We have 3 parallel lines, and this time you'll notice that these are all, this whole thing is a transversal. Sorry, let me start there. This whole thing is a transversal, and all of these are marked as congruent. Well, if these lines are parallel and these are all congruent, that automatically makes all of these congruent to one another as well. So what all you have to do really is take your 2x minus 6 and set it equal to 12. You're not going to use all 3 pieces at the same time. You don't need to. You just need 2 of them. So add 6 to both sides of your equation to get 2x equals 18. Divide by 2, and x is 9. So if we solve this correctly, when we plug 9 in, we should get 12 here and 12 here. Well, 2 times 9 minus 6 is 12. It's 18 minus 6, which is 12, which is perfect. And 9 plus 3 is 12. So since we got 12 in all 3 places, we know for sure that we set this up correctly. And this is why it's really important for you to actually check your answers, because it's so easy to do something really simple and get it wrong, but it's also really easy to check it and see. Now, if you plugged it in and you didn't get 12, then you would know something wasn't right and you'd be able to at least have the opportunity to fix it. Okay, so now we have 3 parallel lines again, so the triangles, remember those are parallel lines, and 2 transversals. We again have 2 sections marked off as congruent, so if these 2 are congruent, then these 2 over here are congruent. So we actually have 2 different variables to solve for in this problem. We have x and y, so one at a time. 2x plus 4 equals 3x minus 1. Subtract 2x from both sides to get 4 equals x minus 1, and then add 1 to both sides of your equation to get x is equal to 5. So we got x equals 5. The second part of the equation, or second variable I should say, 3y equals 2y plus 2. Subtract 2y from both sides of your equation to get y equals 2. All right, so we're claiming that x is 5 and y is 2. So let's go ahead and check it. Plug x in. 2 times 5 plus 4 gives you a total of 14. 3 times 5 is 15, and 15 minus 1 is 14. So we know for sure that x equals 5 is the answer. And then go ahead and plug in 2. 3 times 2 is 6, and 2 times 2 is 4, plus 2 is 6. And those match as well, so we are good. So notice how over here, these 2 are not congruent to one another. It's within the same line, within the same transversal, that those segments are congruent. All right, and now for our last example. So we have, again, 3 parallel lines, notice the triangles, and we have our 2 transversals. Nothing is marked as congruent this time, and so what that means is we have proportions. So I'm going to go ahead and take this 3, and I'm going to put it over x, so 3 over x, and set that equal to 4 over x plus 4. So I use the smaller over the larger. So again, I do smaller over larger. Keep it consistent. Do your cross multiplying. Don't forget that the 3 has to be multiplied by the x as well as the 4. So you get 3x plus 12. Then cross multiply here to get 4x. Subtract your 3x from both sides of your equation, and we get 12 is equal to x. So let's go ahead and check that just to make sure that it's right. So 12, and then we're saying 12 plus 4, so that this one is 16. 3 over 12, is that equal to 4 over 16? And if you divided it out, you would see that you get 1/4 equal to 1/4. So we are good. We have the right answer. X is 12. All right, so basically just more proportions and, knowing how to set them up. And then with this one, the previous example, I mean, that's super easy. It's just congruent. All you do is set them equal, and that's not even new at all. So you should be totally okay. Make sure that you have all the examples and any questions that you have ready to go.